The point load test is an accepted rock mechanics testing procedure used for the calculation of a rock strength index. This index can be used to estimate other rock strength parameters. The focus of this test is to present the data analysis used to correlate the point load test index. The rock strength determined by the point load test, like the load frame strengths that they estimate, are an indication of intact rock strength and not necessarily the strength of the rock mass. Depending on the shape of the specimen, the point load strength index can be derived via three different types of tests: diametral, axial block, or irregular lump test.
This is the apparatus that we should be using. First is the point load strength test machine, and a 100mm scale attached to the loading frame. And lastly is the pressure gauge, which is that have the capacity of 25 kN or 50 kN. Type of test conducted on rock sample with small length is axial test. Granite was used as rock sample for the test. Next, the total diameter and width of cone samples are measured. Acceptable range for the diameter over width lies between 0.3 to 1.0. The sample is placed vertically between the two platens. Next, the measurements of the distance between the platens contact and parts was taken using the seal attached to the loading frame. The tolerance is plus minus 2%. Later, the scale meter at load applied is then set to 0 point. Then, the load is applied to the cone sample with steadily increment and failure loads P is recorded. The test result is considered invalid if the fracture structure passes through only one load point. The last step is we need to repeat the step 3 to 6 for the other two samples.
So moving to the result and calculation part, we have drafted the table showing all the 9 most important parameters of this experiment of these 3 samples. In the first one, diameter, and then followed by width, load, and minimum gross sectional area, equivalent core diameter, size correction factor, uncorrected point load strength, and point load strength, and finally unconfined compressive strength, which is short form UCS. As the below part shows the calculation on how we conducted each parameters, and we can see a clearly difference between the first 2 samples. We can say that the first and the second sample has quite similar value of point load strength, but for the third sample, it has a point load strength that's way lower than these two first and second samples. So what happens to the third one? As we can go back to the second and third column, we can see that the diameter and the weight of the third sample is way much smaller than the first and second sample. So, and the load applied on it is also smaller than first and second sample. So that's the reason making it unconfined compressive strength way lower than the first 2 samples.
So now, let's move to the discussion of the experiment. At the end of the experiment, we obtain the unconfined compressive strength for the 3 samples that we use in this experiment. In this experiment, we can observe that there was a human error associated with the imperfect alignment of axial of sample and joints of the point loader. This human error is a must to be included in consideration as it might affect immature failure at test sample. The reason for this is because crack propagation will be invalid in the material. Moisture content affect the strength of the rock sample. Moisture will weaken a rock sample, meanwhile, rock sample without moisture content do not fracture easily. Moisture content which could have been pre-existed in core samples or existed due to moisture absorption from surrounding environment played an important role in the test. From the result, we can determine the compressive strength of the rock specimen from axial test.
From the results, we have obtained the compressive strength of the rock sample. Therefore, we have achieved the aim of the experiment. Point load is a test that aims at characterizing rock materials in terms of strength. It is an index test, meaning that it can be performed relatively quickly and without the necessity of sophisticated equipment to provide the important data on the mechanical properties of rocks. Therefore, the point load test enables economical testing of core or lump rock samples in either a field or laboratory setting.